We're working on developing hybrid wheat, and what a hybrid is the cross between a male inbred parent and a female inbred parent. And what the benefit of hybrids is that you're really combining the best of both parents together into one. Hybrids tend to, at maximum benefit would be about 15% over a pure line. Currently we're at 1% gain per year for yield, and we really need to be at 1.7 to meet the future demand. Hybrids effectively would equate to about 15 years of breeding if we deployed them right now. Where hybrids really shine is in the suboptimal conditions, and what I mean by that is under drought we actually saw that 25% of our hybrids beat the best commercial check, wherein under optimal conditions only about less than 10% beat the checks. The big reason why we haven't deployed hybrids yet is because the cost to produce them is too high. And the biggest way we can reduce the cost to produce them is by increasing the amount of available pollen to cross-pollinate. Wheat is a self-pollinating species, and so we need to redesign the architecture to increase pollination. We've used a association mapping population, which is a diverse set of different inbred lines, to look at a couple of key traits, with the main one being called anther extrusion, which is how well those anthers come out of the spike. So we want more anthers out of that spike, the more the better. And we rated them. We've rated this population for a number of years, and actually found that it's very repeatable. So a lot genotypes that are always good, or that are good, are always good, and genotypes which are poor are always poor, so they don't push a lot of anthers out. It's a difficult trait to measure, meaning that you can rate them in the field visually, but you're not going to be able to do many locations and really test to see what genotypes are truly good in all environments. And so if you can develop molecular markers, you can screen a much larger set of genotypes. We found one novel set of markers on chromosome 2A, and although it only accounted for about 4% of the genetic variance, which is a very small amount, it actually separated out the best and worst lines. So we could actually deploy that for selection, and also in a gene pyramiding type of approach, where you screen your genotypes for those markers and then rate the ones that only have the best marker scores.